Assalamualaikum, my name is Ahmad Dini Ashraf bin Zul Azlan. In this video, my group members and I will present to you our group project assignment for the subject Linear Algebra 2, which is MAT523. For this project, we want to find the fit curve on the death rate in Malaysia. As we know, the death rate are measured by the number of deaths per unit time in a population. The statistic can be used to measure the overall health of a population. Among the causes of deaths, mortality rate includes accidents, substance abuse, and suicide. So, we want to determine whether the change of rate of death in Malaysia correlates with the number of deaths. Thus, we use three mathematical methods, which is linear method, quadratic method, and cubic method. So this is the table data set of the Malaysia death count from the year 2004 to 2023, which is shows the relationship between the death rate as X and annual change as Y. So by using mathematical method, we are required to find the best fit curve and the error magnitude. As the result, we can determine which mathematical will give the best approximation and has minimum error in terms of its magnitude. Firstly, I will begin with the basic mathematical method, which is linear method. As you can see here, the equation for the linear model is y equal to a plus bx. Therefore, from 20 data that we have, we can substitute the value of x and y into the linear equation. After that, we can set up the matrix for m with dimension 20 by 2 and the matrix of y with the dimension of 20 by 1. Next, we need to multiply the transpose of matrix M with matrix N. The transpose matrix M has dimension 2 by 20, while the matrix M has dimension 20 by 2. So the answer will be the matrix with the dimension 2 by 2. Next, we need to inverse the matrix of M transpose M, and we will get the answer. We also need to find the answer of the transpose M multiplied by the matrix Y, and the answer will be the matrix with the dimension 2 by 1. After all the calculation, we can obtain the least square solution by multiplying the inverse matrix M transpose with M and matrix transpose with Y. So we get the value of A and B. Then we can get the best fit linear curve by substituting the values of A and B. Besides, to find the error vector, we need to subtract matrix Y with the matrix MV. Lastly, we will get the magnitude of error vector, which is 0.794291. So this is the graph for the best fit curve of linear model, and this is the graph of residual error vector around the x-axis for the linear model. Note that both of graph will obtain from the Maple application.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shami bin Rosli and my student ID is 2023862792. Next, I will continue on the quadratic model. Quadratic model is a mathematical model represented by a quadratic equation, which is y equal to a plus bx plus cx squared. Then, from the 20 data that we have, we can substitute the value of x and y into the equation, and we will get the result as below. Then, we need to change the equation into a matrix form. Then, we need to set up a matrix which is equal to mv equal to y. Then we will get the answer like this. Then we need to find the value of m transpose m. Then we will get the answer as below. After we get the value of m transpose m, we need to find the determinant of m transpose m. So as we can see here, the determinant of m transpose m is equal to 4.0418, which is not equal to 0. Then we can conclude that the inverse of m transpose m, it exists. After that, we find the inverse of m transpose m. Then we will get the answer like this. After that, we also need to find the value of M transpose Y. Then we obtain the value of M transpose Y is equal to this. Lastly, we need to substitute all the value that we find just now into a formula V equal to M transpose M inverse times it with M transpose Y. Then we will get the answer V is equal to 3 by 1 matrix with the value of the first row is negative 45.5611, the second row is 17.4264, and the third row is negative 1.6089. Then we can also write it into a quadratic equation, which is y equal to negative 45.5611 plus 17.4264x minus 1.6089x square. Then we need to find the error vector by using a formula E equal to y minus mv. After we substitute the value of y, m and v into a formula, we will get the answer like this. And lastly, we need to find the magnitude of error, and we will get the answer which is equal to 0.57819. For the graph, as we can see here, the left side is the scatter plot graph of our data, and the right side is the quadratic graph for our equation model. Then, as we can see here, the left side is the best fit quadratic curve graph of our model, and the right side is the graph of residual or arrow vector of our model.
Hi, my name is Muhammad Amir Irfan, and with me, let's talk about the cubic model. And cubic model is the same as the other models. We just cube the equation from the previous model. So the equation for cubic model is y equal to a plus bx plus c x to the power of 2 plus dx to the power of 3. And this is the cubic equation. And continue to another slide. Hi, me again. And this all the 20 data that we get, and we put to the cubic equation, and we get this cubic model. And with this cubic model, we can get mv equal to y, m transpose m transpose m inverse, and m transpose b. And so let's continue to find all of this equation. M transpose m. So looking at the formula, we put the matrix in its order, and after that we find the determinant, which is we get the positive number, hence we can find the inverse of this matrix. Hi, continue. Let's find the m transpose n inverse, and we calculate that, and we get the inverse for the matrix. We put this on hold, and let's find another equation. To continue, let's calculate the m transpose y, and we put in the matrix, and we will get the final answer 19.9900, 99.9193, 501.1863, and 2522.5989. And with this, we can calculate the v value. Let's continue. So now we can calculate the v value. So looking at the formula, we just input the equation that we get earlier into the formula, hence we get the value for v. So with this value, we can create the cubic equation that is can be seen in the box below. And don't forget to calculate the error vector, which is the equation will be y minus n v, and from this equation we will get the error vector will be 0.550882, and this number will be useful to us next slide. And this two diagram shows that the scatter plot for cubic graph and the cubic graph itself. And this two diagram shows that the scatter plot and the best fit curve and the graph for the error vector or the residual graph. For conclusion, as we calculate all the equation and error magnitude for the three equations, we conclude that the cubic best fit curve is the best because it have the minimum error term in its magnitude. Hence, we end our research. Thank you.